Hello geometry students. I humbly come before you with a new video about the law of detachment and syllogism. If you did not watch the other video I posted on Google Classroom, it's the one by Mario. You need to pause this video, go back and watch that one, then you're ready to watch this video. Okay? So, do that if you haven't done so already. Otherwise, let's get started. So this one's just a matter of making sure that we understand symbols and logic notation. So when you see this little squiggle right here, it's called a tilde, and it means the opposite of or not. It means to negate the statement we're talking about, to make negative, oftentimes, I'll just say it's not. So, tilde P means not P. And here's what it looks like over here. I gave you two statements. The P represents the hypothesis. The sky is cloudy. The Q is the conclusion. It is raining. So, not P means the sky is not cloudy. Right? And then the not Q would be, it is not raining. So pretty basic notation to start out with. Now what happens if we have one of these little arrows? The arrow means it follows that. Or you could say it means implies. Let's see, can you guys see this? Let's adjust. All right, we're good now. So when you see Q, arrow, P, it's basically saying if it is raining, it follows that the sky is cloudy. Okay? So, if it is raining, I just make the Q the if part, if Q is on the left part of the arrow. Then it follows that the sky is cloudy. You don't actually have to write implies or it follows that. You can just put the then part. Then the sky is cloudy. Right, so if you see a tilde in front of the Q and a tilde in front of the P, not Q implies not P. If it is not raining, then the sky is not cloudy. All it did was reverse the P and the Q and made them both negative. All right, so why don't you guys go ahead and pause the video right now and see if you can do number 5 and 6 on your own without me explaining it for you. All right, let's see if you guys got the right answer. P, if it is cloudy. Actually, what is it? If the sky is cloudy, I've already forgotten. What is it? Come on now. If the sky is cloudy. If the sky is cloudy, then it is raining. If the sky is not cloudy, then it is not raining. So check yourself. Did you write it properly? Did you put the nots in there where they belong? Did you put it in the right order? Is the if followed by this? Is the then followed by that? All right, because right now logic has to be super specific. You can't just throw a bunch of words on paper and expect it to all come out right. It's very specific. All right, so quick recap of law of detachment from Mario's video. So let's talk about this statement. If it's Sunday, then students are not in math class. All right, so take that statement for a minute, okay? The law of detachment basically says we're assuming that the P statement, which is it's Sunday, follows that students aren't in math class. That's a true statement. If it's Sunday, you guys are not in my classroom. Now, what they're saying is P is true. If we can establish that we've got that scenario, we know it's Sunday, then it must follow that students are definitely not in class. So what they're looking for is basically, does the statement given satisfy the initial condition? So you might get something like, I don't know, it's November 29th, 2020. Let's say that that's the statement then given. Is there a conclusion? Well, November 29th is a Sunday, so the conclusion is students aren't in math class. That would be by law of detachment. Students are not in math class by law of detachment. By the way, you can't reverse that either. You can't say, hey, students aren't in math. Conclusion? There is none. What if we're talking about remote learning? You guys weren't in class on Thursday last week. You weren't in class on Friday. You weren't in class on Wednesday, nor were you on Tuesday or Monday. What if you're in Mr. Benton's class? What if you're in some other class down the hallway? So, students aren't in math class. You cannot use the law of detachment to suddenly reverse engineer your way back to Sunday. There is no conclusion. This is sort of like, you might say invalid, that there's no conclusion to be made from that. So that's the law of detachment, kind of in a nutshell. The law of syllogism. Let's see here. I should have thought of something ahead of time. All right. If you have a driver's license, then you are at least 16 years old. Let's just say that that is for sure a true statement. If you're at least 16 years old, then you hold on one second. Oh man, the pressure is on because the video's rolling. It's gonna be on YouTube soon. You know what? This isn't my best work, but I'm going to go with it. If you're at least 16 years old, then you have graduated kindergarten. Let's just say that that's true. So, you've got two statements. If you have a driver's license, then you are at least 16 years old. This is P. You have a driver's license implies Q. You are at least 16 years old. What the law of syllogism says is that it then takes the Q statement and makes it the if. If you are at least 16 years old, then you have graduated kindergarten. So what's the conclusion of that? Here's the statement. You have a driver's license. Based on this right here, you can conclude that you've graduated kindergarten. Sorry, I just started writing in all caps randomly. Kindergarten. Yeah. Similarly, like with the law of detachment, I can't just take a random statement in the middle of this and kind of move forward with it. The flow of logic starts with P, goes through Q twice to get to R. So I can't say, hey, my nephew graduated kindergarten. I can't suddenly move my way back to he's 16 years old or that he has a driver's license because he's not 16 years old and he doesn't have a driver's license. Similarly, we can't say you are at least 16 years old and then go to the fact that you have a driver's license. You can't go that way either. I was 16 years old on May 8th, 2000, and man, when was that? 2002, I believe, and I didn't have my driver's license at that time. I had to wait, I think, a couple more weeks after that. So, yeah. I'm going to stop the video here and then make one more video where I go over the second page of notes where we just talk about law of detachment, law of syllogism, and hopefully I can recover from this statement right here. All right, thanks.